Let me show you how to do some coding. Press your program key, then select New. Press Enter, and now give your program a name. I'm going to use my alpha key. It's already locked on alpha, so let's see. Let's call this C, and let's call it COS for the cosine function. All right, so press Enter. Now we're ready to program this. What we want to do is go to your program key again, and notice you have all these choices here. You want to pick the IO, that stands for input output, so scroll over to that. Scroll down to prompt, press Enter. Now I'm going to prompt the user for some data, and if you recall in the law of cosine, we needed one of the sides of the triangle, or it could be the magnitude of a vector. I'm going to call the magnitude of the first vector or side, I'm going to call it A, so I'll prompt alpha A. Okay, and press Enter. I'll go back to your program key, go back to input output, select prompt again. We're going to do separate prompts. We could do this all at once, but we'll do separate prompts, just keep it simple. Now let's prompt for the other side of the triangle, or the other vector. I'm going to call it alpha B. Alpha B. Alright, and we'll also need an angle, so let's enter this. Let's go back to program, input output, select prompt again, pick that, and now we need an angle. And what we'll do is we'll do alpha, and then right here where the 3 is, you can see the symbol theta, put that in. So now we got A for one of the sides of the triangle or vector, B for the other side of the triangle or vector, and then we have the angle, and this angle will be the angle between the two sides or two vectors. So press Enter. And now I want my calculator to do the law of cosine for me. I have to put in the formula. So let's press program again, go to input output, and this time pick choice 3 where it says DISP. That stands for display, but it will also calculate a formula that you put in. So we're going to pick that one, third one down. Now let's put in the formula, and I'm going to show you how to do this. You have to be a little creative when you do this. I'm going to use some parentheses and brackets here, or braces. So I'm going to start off with doing my second key, and right here I'm going to put in that little brace, and now I'm going to do A squared, so alpha A, and I'll press my squared key, and then to that I'm going to add to it. Can you guess what it's going to be? Well, it's going to be alpha B squared. Here's my square key right here. That is the Pythagorean theorem part. Now what I want to do is put a plus instead of a minus, because this angle is going to be the angle between the two vectors. So we change the law of cosine from minus to plus. Now I'll do the rest of the law of cosine. If you recall, it goes 2 times A, I'll just put in alpha A, times B, I'll just put alpha B. And now I need to do the cosine of that angle. So if on the cosine key, press that, put the angle in, I go alpha, angle's down here, key 3, and put a parenthesis in, and I'm going to put another one of those braces in. I'll do second, this key right there. Okay, that's looking like the law of cosine. We have A squared plus B squared plus 2AB cosine theta. Now I need to take the square root of this. Now one way to put the square root in, you can put it in as a power. The square root actually is something raised to the power 1/2. And I'm not going to use 1/2, I'm going to use 0.5. So to raise this whole thing to the 1/2 or 0.5 power, what I'll do is I'll use the caret key, and then I'll put in 0.5. Now this is the law of cosine modified with the plus in the middle, and the raising something to the 0.5 power is the same as taking the square root of it. So this should work for us. So let's test it. What I'm going to do is I'm going to quit out of this, second quit. I'm going to go back to my program key, and notice I have execute here, and I can pick number 1 there. Just press enter, and I'll press enter again, and it will prompt me for what side A is. Now if I look back at the test I had you guys just take, Let's see what we had here. We had a hiker walks 4.5 kilometers in one direction, then makes a 35-degree turn to the right and walks another 6.4 kilometers. What is the magnitude of the hiker's displacement? Well, if you were to draw this out, you would find that the 4.5, well, that's one displacement vector, so I'll put that in, 4.5 for A, and press enter. And it prompts me for B. Well, the other vector, or displacement vector, is 6.4. I'll put that in. And I'll press enter. Now it asks me for the angle. Now if you draw this out, you'll realize that 35 is the angle between those two displacement vectors if you connect them tail to tail. So I'm going to put in 35. Now I should get the right answer if I'm in degree mode. Let me second quit out of this for a minute. I want to check my mode. Now notice my mode is in radian mode. I need that to be in degree mode. So I need to scroll down here and put it in degree mode. Alright, now I'm going to enter that. I'm going to second quit out of that. Let's go back to my program. Program, execute again. Let's put in, press enter again. Let's put in 4.45 again. Let's put in 6.4. And now let's put in the 35. Now the 35 will stand for degrees and not radians. When I press enter, I should get the answer. And the answer is 10.4. That would be 10.4 kilometers. That's the answer you should have gotten on the test. So you could use this to figure out any vector problem where you know the two vectors and the angle between them. Let's just make one up. Now if I press enter again, it'll run the program. Let's say one of the vectors is 10. And another vectors is 6, like that treasure chest worksheet I had you do. And let's make the angle 60. If you recall, that one with the angle of 60 was the maximum force. And let's see what this gives us. Yeah, 14. That's correct. Let's do another one from that treasure chest worksheet. We had 10. Then we had 6 again. Let's put in 90. We can put in 90. This would be a right triangle, and we could just use the Pythagorean theorem, but the law of cosine will reduce to the Pythagorean theorem when theta is 90 degrees. So let's see what we get here. Yep, 11.7. Yep, that is correct. Let's do one more. Let's do 10, and let's see, 6 again. Let me recall what the other angle was. I think it was 135 on that sheet we had in class. So let's see what this is. Oh yeah, 7.2. So if you notice, let's see if we can scroll up here. Oh, it looks like it's all finished here. Can't scroll up. If you notice from that, we had the maximum was the one with the 60-degree angle, and the one with the 135-degree angle, that was the minimum. So if we take two vectors again, let's put in the program, enter, let's just do it again. If we do 10 and 6, and do 60 again, we get 14. Now if we make that angle more, do it again, 10 and 6, and we had 135, notice that it becomes much less. And recall the minimum would be 10 minus 6. That's when they're in opposite directions, and the maximum would be 10 plus 6. Now let's do the maximum on here. Let's put in 10. Let's put in 6, and let's put in 0 degrees. Look at that, 16. And how could we put in the minimum? Well, let's try it. If we put in the minimum, we would do 10. 6, and we put in 180 degrees. That means they're pointed in opposite directions. And there's 4. See, 4 is the minimum, and 16 is the maximum. So you could have actually used this program to do that sheet of the treasure chest. Might want to look back at that and do that. So, once again, I would like you to program your calculator. Let's look at the program one more time. I can press the program. I can always go to the edit here and then press it again and see what the program looks like. This is what it looks like. There's a few other ways to write this, but you really only need to know two functions, the prompt key and this display key. You prompt for the variables you need in the equation, and then you use the display key to write the equation. You might have to be creative on how you write it, and you might have to test it a few times, see if it works, and make changes if needed. And this is all you need to do to write your own programs that will do a lot of these formulas that can be rather complicated. I'll continue to show you more of this in class, but please put this program into your calculator, and I'm going to have you try a few programs with it, or a few problems with it, and see if it works. Thank you.